Welcome back, Bobcats. This is Mr. Day. Today we're going to be doing Chapter 3, Lesson number 12, Interpreting the Remainder. So let's read the adjective together. Let's begin. I will interpret the remainder in a division problem. Alright, so we're going to take a look at the leftover after we have divided and gotten our quotient. Let's take a look at our remainder, the leftover portion. Let's first take out our notebooks. Let's write down our vocabulary term, which is remainder. Please make sure you have the heading of 312. And let's write down our definition of remainder, the number that is left over after one whole number is divided by another. So I have given you there an example of a division problem. The divisor, the dividend, the quotient, and yes, the vocabulary word for today, the remainder. That is the part that is left over, the part that cannot make another group out of. So we're going to be discussing what does that exactly mean. Alright, so if you need extra time, go ahead and pause the video, write down the vocabulary, write down the example of the vocabulary, and all of the meanings, quotient, divisor, dividend, and of course the remainder. Alright, so let's first take a look at this question. What is the meaning of a remainder? So let's write down an example problem in our notes. What does the remainder, what is the meaning of it? So let's give an example problem here of 94 divided by 4. So if I go ahead and divide this problem, 9 divided by 4, I multiply 2 times 4, I get 8, I subtract, I bring down, I divide 4, 14 divided by 4 is 3, I divide, multiply, I subtract, and I have this 2 left over, which is going to be my remainder. So what does this 2 mean? That means if I am making groups of 4, since I am dividing by 4, this is the number I am making. I'm making groups of 4, meaning I can make 23 groups of 4. And after I've made 23 groups of 4, I'm going to have 2 left over. And if I have 2 left over, so if I have a group, 1, 2, meaning I do not have enough to fill a group of 4. And that is exactly what I have here. Okay, 2 left over, meaning I do not have 4 to complete an entire number, another group. All right, let's consider the second question here. What does a remainder of 0 mean? So let's take another example here. Write this in our notes. So let's take 75, for example. Divide it by 5. So if we go ahead and divide this and multiply and subtract and bring down and divide and multiply and subtract, I end up with a remainder of 0 here, meaning that our quotient here, 15, there are 15 groups of 5 for a total of 75. And we could take, for example, money. Let's say I had $75 and I was putting it into 5 different piles. There would be $15 in each pile. And since I have a remainder of 0, there would be none left over. There would be no money left over after I split it into groups of 5. Remainder, that's all that 0 remainder tells us, is there is nothing left over. We've used all of our units. All right, let's discuss a little further this meaning of remainders. So let's take this situation. So how many groups of 3 can be formed by our class? Model the solution by forming groups and counting, and then find the quotient of the number of people in the class divided by 3. All right, so we have 26 people in our class. So since we have 26 people and we want to put them into groups of 3, so I need to take these 26 people and divide them into groups of 3. So showing that mathematically, we're going to take our 26 students, that's you and everyone else in the class, and we're going to put you into groups of 3. So how many groups can we form? So if we go ahead and divide here, 3 goes into 26. How many times? It would be 8 times. We multiply, we get 24, and we subtract, we have 2 left over. So we have 8, remainder 2. So what does this mean? Well, this 8, please put this in your notes, by the way. We have 8 groups, right? That's what the 8 means. What does this 2 mean up here? Well, this remainder that we have left over, this is the number of students that are not going to be in a group. So that means we have 2 students not, and I'm capitalizing, not in a group. So we have 24 students in a group, but we have 2 that are not in a group. That's kind of what it means. All right, let's take out our practice books. Please open it to page 227, if you would. Let's take a look at our sample problem, or example problem, number 1. A state park has 257 evergreens to plant equally into 9 areas. How many evergreens are planted in each area? All right, so they have given us the expression. We're taking the number of evergreens and we're putting it into 9 different areas, chopping it into 9 pieces. So what do we get? 257 divided by 9. So let's go ahead and solve this division problem, and then we'll go ahead and talk about what the pieces mean. So 25 divided by 9 is a grand total of 2. 2 times 9 is 18. 25 minus 18 is 7. They brought down the other 7 for us already, so we have 77 divided by 9. That is 8. 8 times 9 is 72. We subtract, we get 5. 5, of course, goes up here. That is the part that is left over. So let's talk about this, what we started with. So we started with 257 evergreens that they're going to put into 9 different areas. So what that means is we're going to be able to put 28 trees into each section or area that they want to put it in. That means that there's going to be 5 trees that are going to be left over. As you can see from the picture here, we're going to have 5 lonely trees that do not fit into those areas if they want to put them equally. So interpreting down here, let's go ahead and do number 5. Interpreting the remainder 5. The remainder 5 means there are 5 evergreens left over. It's the number we started with. We're putting them into 9 different sections. That 5 simply means that's the number that is going to be left over. The remainder, the extra part. All right, example number 2. Let's take a look at this one. In this case, we have 174 guests. Let me get a red pen. It'll be easier to see. And they are invited to a dinner. That is a big dinner, isn't it? Each table has 8 guests in the seats. So how many tables are needed? Imagine if you're at a wedding and you had 174 people coming. And you could have tables with 8 people. How many tables are you going to set out so that people do not have to stand and eat their dinner? So let's figure this out. Here is our expression. We are dividing 174 divided by 8. they have that set up for us. So let's go ahead and solve the problem here. So 8 goes into 17 2 times, which is 16. We subtract, we get 1. We brought down our 4, which becomes 14 now. 14 goes into 8 1 time. We multiply, we get 8. We have 6 as a remainder, which we know goes up into our answer. So, all right, so if we have 21 with a remainder of 6, that 21 tells us that's how many tables we're going to need, right? Let me change colors here. So this 21, that is the amount of tables. That's how many tables we're going to need. We have 6 that are left over. Are you going to make Uncle John and Aunt Sally sit or stand rather than sit? Well, I guess the logical thing is, kind of like those videos we watched on the last lesson, or 2 lessons ago, is, well, the logical thing is we're not going to need just 21 tables, but because we have this remainder, this is a case where we're going to run a round up, if you remember those videos we watched. So we don't want 21 tables, but we're really going to want to have 22 tables, right? So that those 6 people that are left over do not have to stand. All right, let's go to the bottom of the page and take a look at our guided practice here. So it reads, a tent is put up with 7 poles. So they want to know how many tents can we put up if we have 200 poles. So the key pieces of information there. That is for each, and this is the total amount we have. So let's take our total, and we're going to divide it by 7. So let's go over here to the side and go ahead and work this problem out. So we have a total of 200 poles, and it takes 7 to put up each tent. So how many tents can we put up? So let's divide. So 7 divided by 20, that would be 2, be 14, we subtract, we get 6, we bring down our 0, 7 can go into 69 times, which is 54, we subtract, we get 6 left over, so it's 29, remainder 6. So now let's think about what this means. What exactly does this 29 here mean? This 20, let me do it in black. This 29 means that's the number of tenths that we can make, right? So let me write down, that's the number of tenths. So what does this remainder 6 mean? Well, that's how many poles I'm going to have left over, right? That's the number of poles that are left. Can I make a full tent with 6 poles? Well, no. It said right here that we need to have 7 poles to make a tent. You want to sleep in a tent where half of it's going to be falling down because you don't have enough poles? Probably not. So the most we can make with that amount of poles is 29. This isn't a case where we're going to round up. This is a case where we're going to ignore what we have left over because we can't make a complete tent. You just got to think about these problems logically. Put yourself in that situation. Trying to make tents, we can only make 29 of them. All right, so let's take a look at this problem here. Let's read it. Valerie has 20 stuffed animals. She wants to store them in plastic bags. That's a good idea, so they don't get eaten by the critters. She estimates she can fit 3 stuffed animals into each bag. So how many bags is she going to need? Well, we have what? 20 total stuffed animals. And it says that she can fit how many? 3 in each bag. So we're going to take the 20 stuffed animals and we're going to divide them into 3. Right? Because that's how many can fit into each bag. So let's solve this problem first. Let's go ahead and go down here and solve it. So we're going to take our 20 stuffed animals. We're going to put 3 in each bag. So how many bags are we going to need? 3 goes into 20 6 times. multiply, I subtract, I have 2 left over. So I have 6 remainder 2. So that 6, what does that 6 mean? This 6 here, that is the number of bags, right? Now what does the remainder 2 mean? That's what's left over, right? So what are you going to do with those 2 stuffed animals that are left over? Are we going to throw them away, or are we going to put them in another bag? We're obviously going to put those into another bag. So this is a case where, yes, we need 6 bags, but we don't need 6 bags. We need to actually add a whole nother bag here for what is left over. You're going to have 1 bag of just 2 stuffed animals. So really, in reality, she's going to need 7 bags altogether. That's the common sense of the problem. All right, so we've reached independent practice. I would like you to go ahead and read this problem. I'd like you to solve it on your own. Pause the video. And then once you've completed the problem in your practice book, come back and listen to the answer and see if you've gotten it correct. All right, so let's take a look at this problem here. It says there are 50 students traveling in vans on a field trip. Each van seats 8 students. How many vans are going to be needed? All right, so we have 50 students, right? And we're going to divide those 50 students by 8, because that's how many can sit in each one of the vans. So let's go ahead and divide these students. Let's do it right here. So if I have 50 students, I'm dividing them in 8 because that's how many can fit into each van. Go ahead and divide here. 8 times 6 is 48. I subtract, I get 2. So I have 6 remainder 2. So let's interpret this now. So what does this 6 mean? This is the number of vans, right? So that's how many vans. What is this 2? This 2 is the number of, these are students, right? So what are we going to do with these 2 students that are left over? What makes sense? What is common sense with these 2 students that are left over? Are we going to leave them behind because they don't fit exactly into the vans? No, that's not common sense. This is a case where we're going to have to take the number of vans and we're going to have to add 1 because we have these 2 students that are left over and we're not leaving those 2 students behind. So in reality, we're going to need 7 total vans, because we have to account for these students that are left over, the remainder of the problem. All right, it's come to the end of the lesson. Time to think about what we learned today. So take 15 to 20 seconds and think about all the things I've talked about, things that you've done in your practice book. And we're going to have a quick discussion. Remember to use our academic language, our vocabulary word of remainder, divisor, dividend, quotient. We're incorporating that into our vocabulary. So in your discussion, your sentence frame in summary, today I learned, and discuss what you've learned with your group mates. Go ahead and discuss now.